Welcome to the PrepNet, presented every Sunday at 6 p.m. Eastern Time on Talk2Me's Channel 14. Come join us to discuss everything about prepping and hear what others have done. All About Electricity, Part 15, Lithium Iron Phosphate Batteries. Charge Controllers, Part 2. We'll conclude the discussion on charge controllers by discussing key considerations to keep in mind before purchasing a charge controller. The larger charge controllers, both PWM and MPPT, can typically charge a wide range of battery voltages and accept higher input voltages. This gives you more options when designing your electrical system. It will also provide you with room to easily expand your system without needing to purchase a new, larger, and more expensive charge controller. My recommendation would be to get a larger charge controller in the beginning rather than a smaller one. Easy expandability should be part of your electric backup system design. Next, you must match the voltage of the charge controller's output to the voltage of your battery system. If you have a 12-volt battery system, you will need to get a charge controller that will work with a 12-volt system. Many controllers will work with 12 and 24-volt systems, and some can handle 12-volt, 24-volt, and 48-volt systems. To give you an idea, my main charge controller can charge a 12-volt, 24-volt, and 48-volt system. You might ask, why not just get a charge controller to charge the voltage of your battery bank? Well, my main backup system is 24 volts. However, I still need to charge the 12-volt portable battery packs I built. I could run a 120-volt AC battery charger from my main system to charge those 12-volt batteries. However, this would use stored power from my main system, giving me less capacity for my other electric equipment. By using a second charge controller and solar panels, I can handle both my 12-volt portable batteries and my 24-volt main battery bank without taking any power from my main system's batteries. With my secondary charge controller, I can easily charge my 12-volt portable batteries or supplement my main 24-volt system with additional charging. As shown here, this is the main battery bank, charge controller, and solar panels. Solar power from the panels goes into the charge controller. The charge controller does its magic and charges the battery bank. Now I add the secondary charge controller and solar panels. If I connect that second controller to one of my 12-volt batteries, it will auto-configure and charge it at 12 volts. If I connect the controller directly to my 24-volt system, it will automatically configure itself to charge at 24 volts and will supplement my main battery bank solar array and charge my main battery bank faster. You also need to get a charge controller that will handle the amount of power that your solar panels produce. If you will have 10 amps from your solar panels, you must have a charge controller that is rated at a minimum of over 10 amps. If you have 35 amps of solar power, you will need at least a 40-amp charge controller. You can't use a small 8-amp charger controller and put 20 amps into it. You will burn it out. My main controller is rated at 80 amps, though I'm usually not putting in more than 20 amps into it, but I can expand my solar input by more than 3 times if needed. By the way, 20 amps input at 80 volts with an MPPT charge controller is a lot of amps at 27 volts going into the batteries. The next thing you need to know: your charge controller must be connected to your system in a specific order, or you will damage it. You must connect the charger controller to the battery first, then you can connect the solar panels. The first reason is that charge controllers don't want power from your solar panels flowing into the charge controller with no place to go, as it can damage your controller. The second reason is that if you have a controller that can charge more than one voltage, connecting the battery first allows the controller to auto-configure to the voltage of your battery. We will cover this in a systems protection topic, but I have disconnect breakers from my solar panels and from my battery bank, so it is easy to activate my charging without having to manually connect and disconnect wires, plus no sparks. Once you have the battery and solar panels properly connected, you don't need to worry about damaging the charge controller when night comes and the solar panel stops producing power. Now, to turn off your charge controller, you will need to do it by disconnecting the solar first, and then you can disconnect the battery last. The programmability of the charge controller. I highly recommend that you get a charge controller that will allow you to change its charging configuration. As with the BMSs we talked about, the default configuration will be the maximum and minimum of an LFP battery system. Not allowing you to change the charge settings will not allow you to get more cycles out of your battery. My charge controller is set to stop sending current into my battery system at 27.7 volts, far below the 29.2 volt default. This gives extra protection to your system, so if a BMS fails, your battery will not be overcharged. I'm not going to cover much of the other configurations of the charge controller, as different controllers will have different configuration screens. I hope this shows you the importance of having a charge controller and picking the correct one for the battery system you have designed. Next week, we'll continue our All About Electricity series and start discussing solar panels. If you have any questions about what we have discussed here tonight, please send your question to prepnetch14@gmail.com and enter question in the subject line.